So welcome, Susanna and Rigny and Alexia, Stefani, Adam, and Antonio. Thanks for coming. And welcome, Diego. So as I mentioned, today's kind of a different day. We're at the end of the quarter, getting close to the end of the quarter. So it's just going to be a review, but I'm also going to go over the quiz that you just took. So let's check out that quiz. Okay, so here's the quiz. And it says, find the Taylor series for f of x equals 1 minus 3x to the 2/5. You may use a formula that was covered in class on Friday. So I think it might help on this one is to find the Taylor series for just kind of writing it out. 1 plus u to the 2/5. Any questions on the idea of doing that? Why would I be interested in that one? Why does that help to make it a little bit easier? And if it helps, let me go back to the big formula, which it gave us 1 plus x to the r. So the idea is it's a little easier not to have to kind of deal with that, this one, the minus 3x. It's easier to just do it with a 1 plus u and then pop it in at the end. So we're going to have 1 plus u, which is just like 1 plus x, to the 2/5. And how does that work? What does it start with? Always? What's the first term? 1. Okay, so that's supposed to be easy. Next one's not too bad either. And what's the next one? So what's the second term? Comes right from the formula. And if it helps, here's that formula again. So it says 1 plus rx. So in this case, it's 2/5. I'm going to write u, though, not x, because x is its own variable. So I'm kind of doing a little substitution to make it easier to write out. Okay. And then again, the formula is right here. It was r times r minus 1 over 2 factorial. So we have plus. And then r is 2/5 times, and again, in the formula, it was r minus 1. What's r minus 1? Yeah, negative 3/5. And then divided by 2 factorial, which is just 2. U squared. So we're getting there. Let's do the next one. Plus, and then it's going to be r times r minus 1 times r minus 2. Okay. Doesn't show the next one, but that's what it is. And it helps to write it out to see what's going on. So we're going to have 2/5 times negative 3/5 times, and if we subtract another one, that's going to give you negative, it's going to be negative 8/5 over 3 factorial u cubed. And then that's going to be plus dot 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 plus, and then just the general formula is going to be 2/5 times negative 3/5 times negative 8/5 times dot 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 times, And then in general, it's going to be, and again, the letter they use, yeah, it's n plus, so it's r minus n plus 1. Okay. And let's figure out what the rm minus n plus 1 is. Okay, so that means what we're doing is we're taking r, which was 2/5, and then subtract n plus 1. And then it is divided by n factorial, u to the n, and then plus ... Okay, and what's the final step? Again, we've used our formula, but what's the final step? So what's the last thing I have to do to make this, to answer the question, basically? Yeah, notice u is negative 3x. So I just plug in, and I'm going to do it by copying and pasting. It's the easiest way. I got the equals already. So everywhere where I see a u, I put in a negative 3x. So we have a negative 3x squared for the next one. The next will be a negative 3x cubed. And then the, I guess, nth term will be negative 3x to the n. Plus ... Any questions on this quiz? Any questions? Okay, let's go to the second one. So it says, use power series to integrate the integral of sine of x squared over x. Okay. By the way, if you think you can do this without power series, think again. Okay, it's not just going to be nice. So we need to get the power series for sine of x squared over x. So who remembers the power series for just sine of x?
Would it be negative cosine of x?
No, the power series for sine of x. Not the derivative, the power series. Or not the integral, I mean. Yeah, we're not taking the integral sign. Yeah, it's negative 1 to the n over 2n plus 1 factorial, x to the 2n plus 1. Okay, so if you don't use that, you can't do this problem, basically. So, but for us, we don't have an x, we have an x squared. So we still have the negative 1 to the n, and we still have over 2n plus 1 factorial. And now instead of x, we have an x squared to the 2n plus 1. And then we still have over x dx. Any questions so far? Okay, so we still got a little work to do. We got to make this nicer. What should we do next? We're not quite ready to integrate yet.
Reduce the divide by x part and take out, make it to the 2n. Or the
Yeah.
x to, yeah, I know that was all confusing, but I think you know what I said.
We got to divide by the x, and we also have to do the x squared to the 2n plus 1 and use the rule of exponents for that. First part doesn't change at all. So I'm just going to copy and paste so I don't have to type the whole thing again. And then I'll make the adjustments. So x squared to the 2n plus 1 is x to the 4n plus 2. But then dividing by x, that's it, dividing by x to the 1, that means take 1 away from the exponent. So it becomes x to the 4n plus 1. Any questions at all on kind of simplifying to make it so that we can integrate? Okay, now comes the next step, which is actually the easy step, I think, which is now we integrate. And the nice thing is that messy -1 to the n over 2n plus 1 factorial, that's a constant, stays a constant. So that doesn't change at all. We're still going to have a sum. So I'm going to do some copying and pasting because that's the easiest. We're going to have a sum, and it's going to be -1 to the n over 2n plus 1 factorial. We're going to have now x to the, when you use the rule, the power rule for integration, means you add 1 to the exponent and then divide by that exponent. So 4n plus 1 becomes 4n plus 2. And then divided by 4n plus 2. There's one last little thing I need to do, which is little and easy. Yeah, plus c, because we're integrating. Okay, and if you want, just to make it, tell the story better, n equals 0 to infinity. Any questions at all on question 2? Okay. By the way, when you look at that, do you recognize this as a function? Could you tell me what function this is, like, nicely? Is it cosine of something? So do you recognize it, yes or no? Yeah, the answer should definitely be no. Okay, no, you should not recognize this, because that's the whole point, is that if you look at the original integral, you could try all you want. You're never going to integrate this one using what you learned last quarter. You can't integrate this. This doesn't have a nice function. So it is true that every nice function can be written as a power series, but it is not true that every power series can be written as a nice function. And kind of the integration should convince you that if there's something you can't integrate, but you can do as power series, you're not going to come up with a nice function for it. Okay. But in the real world, what you're going to do is you're going to write that down, and then you're going to use it for engineering or whatever. You're going to take it to n equals 20 or something and say that's good enough for me, and let that be, and then do your calculations with the first 20 terms or something. So you're going to use a Taylor polynomial. Okay, any questions on that? Any questions? Okay, if there's no questions, I'm going to ask you, are there any questions about anything else? Homework or whatever? Any questions? Okay, we have plenty of time today. Because as you see, unlike normally, I don't have a lecture. This just ends. But I will talk about what's going on in the test a little bit. Any questions? Okay, if there aren't any questions, I think it might be helpful to look at the syllabus again, because we're really getting the end, right? Today's the 14th, and we're getting ready for the exam. So Wednesday is your exam. It'll be regular time, 8:30. Can we do examples? Yeah, we'll definitely do examples, but that's when I get to the talk about the specifics of the exam. And we can definitely do alternating series. Right now, I just want to kind of let you know what's coming. So we have an exam coming up. So again, there's no Zoom session on Wednesday. In fact, Friday will be your last Zoom session of the course, because so we're going to do the exam on Wednesday. It's 8:30, and because it takes longer to type, I give you an extra little bit of time. So it officially ends at 10:15, but if you go till 10:30, Canvas will still let you do it. So let's put it that way. So in terms of how that works, so that's the exam time for exam 2. And then after that, after Wednesday, there's no Zoom session. So I'll be checking my email in case things go wrong, but at least for the first 20 minutes or so. Otherwise it gets boring. Because usually after 20 minutes, if things went wrong. Okay. And then after that, on Friday is going to be review for the final exam. I'll probably go over the exam too, and then we'll talk about the final exam. And the final exam is a week from today, but notice the time. Again, I go what the college tells me to do. So don't shoot the messenger. In the schedule, it says your final exam starts at 8. So I need to start it at 8. And it says it goes till 9:50. And then I'm going to kind of do the same rule as I do for the regular exams. It officially goes till 9:50, but Canvas won't close until 10. So you'll have until 10 to turn it in. Okay, or not turn it in, but hit submit, I guess is the right word. And that's it, actually. So we are actually done in, a week and an hour and, 45 minutes or so. And then the course is over. Okay, so there is no, there's no review, there's no extra sessions the following week on Wednesday. This course really is over a week from today. So that's what's coming up. And let you know a couple things. One more thing on the 18th, because again, today's our last. We're not having a Zoom session on the 16th, so you're not going to hear me talk about it. But on the 18th, there's no quiz. Why is there no quiz on the 18th? Yeah, there's no new material. There's no homework assignment due on the 18th. So there's nothing to quiz you on. So there is not going to be a quiz. So in terms of timing, if you're used to not logging into Zoom, there's a few of you wait. Don't wait on this one, because we're going to start on time. We're not going to turn it off for the quiz and turn it back on. None of that stuff is going on. So make sure that you're there at 8:30 on Friday. And then the other thing for Friday is come prepared with questions. Again, I don't have new material. I'm not lecturing, but come prepared for questions, or if you want to see kinds of examples. The exam, the final exam, unlike exam 2, covers the entire course. So that means you have to like take out those cobwebs and brush them off and bring out stuff that you haven't been doing for a very long time. So for the final exam, you're definitely going to need to do some extra practice, because you haven't done these partial derivative stuff in a long time. So make sure that you're prepared for that. Any questions on the schedule? Any questions? Okay, so again, today you turn in your homework assignment. That might be your last math homework assignment of your life for some of you. Some of you will continue on for a year. I hope most of you do, but some of you only do 1 year. But definitely we're here for you for next year. Okay, if there's no questions about that, let me talk about exam 2. So just to note, exam 2 does not cover anything exam 1 covered. Okay, it's totally separate. So, it can't hurt to review exam 1 stuff, not for exam 2, but for your final, which is in a week. But really my recommendation is practice and review the stuff we've been doing since exam 1. Okay, and kind of in a nutshell, that sequences, series, and power series. Okay, and then all the details surrounding it. So that's exam 2. It covers all of that. The rules of exam 2 are exactly the same as the rules of exam 1. So what do you think your first question is going to be? Yeah, but your name, but more importantly, you're signing, you're signing, I know how you spell your name, but more important, you're signing a document saying I'm not cheating. Okay, that's the main thing. It's not, do you know how to spell your name? It's, do you agree that you're not going to be talking to other people and looking up other sources and stuff like that, that you're just going to be just sitting there for those, hour and 45 minutes, whatever, and just doing the test, or hour or 2 hours. Okay, so that's what question 1 is. That shouldn't be a surprise. The other thing is, just like exam 1, it uses Proctorio. So if Proctorio went without a hitch last time and you're using the same computer, then it should work again this time because nothing's changed. If you're using a different computer, then you definitely want to make sure that you're ready for it, that you have everything set up. Any questions on that? Okay, so that's a big deal, is that it does use Proctorio. I am hoping, crossing my fingers in a big way, that this is the last Proctorio quiz that regular exam that I give in my life. Okay, I don't know if you love Proctorio, but it's not my favorite thing. I want to be in the classroom with you guys and hand a test, and you write it out on paper and then I grade it on paper. So just let you know that if you take next year's sequence, the second year classes, there's no Proctorio, it's all in class. Okay, everything's face to face. But unfortunately, we're still, even though the state is officially opening up tomorrow. I don't know if you heard about that. Our college isn't. So we can't just go back. I asked and they said no. So sorry about that. So the rules are the same as the last one. Any questions so far? All right, just a couple notes, and this is especially important for this exam. And let me remind you on the quiz, I do not expect you to use full, I mean, if you want to, you can, because it might be easier for you to see, but you don't have to use a full equation editor or anything like that, as long as you express what your work is, showing your work and your solution. Whether you type it the way I typed it, I did this on purpose because I'm going to show you can do it this way, or if you want to use the Canvas's equation piece, you can do that. That's totally up to you. The most important thing is it's readable. And then make sure after you finish the problem, you look back at it and make sure it reads. Okay, because if you type in an equation, sometimes it has trouble. So make sure that you've hit submit or you've hit, enter that equation. It really entered it into your box. If not, then it's going to be not good for you. Any questions on that? Okay, so that's just a note. All right, so content. What I thought I would do is I was going to think about maybe I could be silent. And I bet because this exam, unlike the first exam had like so many little details, didn't it? Do you remember? Like every section had a bunch of details, and there were little stuff, nothing too hard, but there were a whole lot of details. Do you agree? This exam's different. This exam has a few things here and there. Each section had 1 or 2 items, but the items are harder. So let's see if you can tell me what's going to be on the exam. I bet you can guess. So let's see. Hopefully all of you can type in one topic that will be on the exam, one kind of thing you're going to have to do. Yeah, so here's a good one. So does this converge or converge? Okay. And then let me mention something. Oops, should be or. Let me mention something is that you must state the test you're using. And I'm going to put test or tests you're using. Okay, and I'll write down the name of. Okay, you will lose points if you don't state the name of the test. Okay, it could have explicit versus recursive. Okay, just let you know, the first piece that you did, because you knew that was the number one, that does a converge or diverge. There's gonna be more than one of those because we spent a huge amount of time since the last exam doing converge or diverge. If I give you an explicit recursive, you're not, I mean, there will be a lot of explicit sequences, but if I ask you to switch from explicit to recursive, or if I give you a sequence of ... there'd only be one of those where you have to do the switch or note. Okay, but converge or diverge, that's a biggie. There are many of those. Okay, what else? Okay, power series. And what does that mean? So what kind of power series stuff? Because that's like, a chapter. That's the name of a chapter. So what are you going to have to do with power series? Okay, power series, interval convergence. There's that diverge or converge, but let's write down. Power series, interval convergence, and let me just doubly note that if I ask for interval convergence, you also must state the name of the test you are using. Okay. Okay, what else? Good, good. So write down the power series for a given function. Okay, and possibly find the function that corresponds to the power series. Okay, what else? My guess is you probably can guess all of it because there's nothing. It's like we don't have a zillion things that we've done. Okay, there's another biggie though. It's come up 3 times, I believe. Okay, derivative integral. That came up once, and that's an important one too. So find the derivative or integral, or solve the diffie-q. Okay, in other words, do the calculus of power series. Okay, what else? Taylor-Maclaurin series. That's basically right out the power series. There's 2 ways. There's using Taylor series or Maclaurin series, and there's also there is doing it by I don't know, memorization, but basically that's the Taylor-Maclaurin series right at the power series for a given function. That's another way of stating the same thing. Maybe I'll even put parentheses. Okay. Find a Taylor / Maclaurin polynomial. And what else? Yeah. So use the remainder theorem. And by the way, that could be for alternating series. It could be for integral test. It could be for a Taylor series. So we had 3 types of remainder theorems. Do you remember that? Okay. And unless I'm not remembering perfectly, I think that's it. You pretty much got them all. Okay, again, do you agree there just aren't that many topics? But that doesn't make this half easier than the other half. I think this half is harder, but there's fewer topics to worry about. Any questions? Any questions on the topics that you should know? Okay, just some notes. I want to remind you, do you remember what I told you what my strategy was when I was a student in calculus to get ready and do real well? Yeah, sun up, sundown. That's a good piece. But some details of what I did on the sun up, sundown. And by the way, sun up, sundown right now is very long. So I was never, our college goes longer than any college I ever went to. So, so we have a lot more sunshine, but it can't hurt, I guess. There's like, if we were in Anchorage, the sun never goes up and down this time of year. So there are colleges that have longer days. But do you remember what I did? Details? What I did is I wrote a test. Okay. So what I did is I said, okay, what do I think the test is going to look like? And then I went and found problems, usually from the book. And I wrote a test. And then I found a friend and we worked together and my friend wrote a test and we handed each other the test and then we did it and then we talked about it. You know, it's a lot more fun to have someone else around. And I know you might be, you know, Zooming with your friend or whatever, but anyway, I'm not saying you have to do that, but that was my way of doing well in math, is that I kind of wrote a test I thought might be on it, and then I worked with someone else and talked about it, so it wasn't just, you know, by myself for 12 hours. Okay, does that make sense? Okay, but you don't have to, but again, it should help. Make sure you do spend some time. Okay, don't just say, oh yeah, I remember doing that, so I don't need to practice. No, that doesn't work. Okay, you need to practice, even if you remember doing it, because it doesn't mean you remember that you're able to do it still without practice. Okay, so what I thought we'd do, at least a little bit of practice, you know, as much time we got about, you know, 45 minutes or so, is I can take requests. Maybe I'll number these because then it'll be easier for you to type in your request. So there's number 1. Here's number 2. Here's number 3. Here's number 4. 5. 6. 7 and 8. Okay. And if you give me a number from 1 to 8, I can give you a sample problem. Okay, find a Taylor-Maclaurin polynomial. Okay, we can do that, which we basically just did for your quiz, but maybe I'll do one that's a little different because you just did your quiz one where you had to find Taylor-Maclaurin, but I'll do a different one. Okay, so how about use the definition to find the first, how about, I'll let you choose. You want to do second degree or third degree?
Third degree.
Third degree. Taylor polynomial for, now I need to go insert equation, f of x equals, how about, let's make one up. If it's gonna be third degree, I don't want to be too evil. That'd be too hard. Sorry, I'm trying to think of one that isn't too terrible. Yeah, this will work. How about e to the x tangent of x? It's a little messy, but it's not too horrible. Centered at x equal, how about 1? Sound like a good question? Okay, what I want you to do, because again, watching me doing it is not going to help you that much to for the exam. Instead, it's much more important that you practice. So I'm going to give you a couple minutes. Let's see if you can use the definition. And when I say definition, what do I want you to show in one word? To show that you're using the definition. Do you remember? Yeah, derivatives. Let me give you a better one word because it says more than just derivatives. Table. Do you remember the table I drew? So definitely need to show your table. That's what you meant. That's what I thought. But derivatives is a little bit too general because that's basically what we've been doing for the last 9 months. So table. So I'm going to give you a couple minutes and let's see if you can come up with it. And by the way, they're not going to be nice. Tangent of, there's nothing pretty about tangent of 1. But that's okay. So don't try to do decimals and that kind of stuff. Just write it out. And e to the 1, is e, but it's not that beautiful. So I'll give you a couple minutes. And I think it's a good idea to practice by typing because that's how you're going to have to do it on the exam. So All right, Susanna, your f prime is a lot meshier than it needs to be. I'd have to look to see if it's right, but it's definitely not the easy way. Because then by the time you get to f triple prime, it's going to be a nightmare for you. So keeping it simple is a good idea. Yeah, definitely don't plug in 0. There's no 0 on this one. Yeah, you can't plug in 0. That's not allowed. Because we're centered at 1 anyway. So I'll give you a few minutes. That's a hint. Yeah, I'm not quite seeing the x minus 1 piece.
Isn't it centered at 1? So wouldn't that make it x minus 1?
No, the derivative. I mean, the derivative is just with x's. Yeah, you're just plugging in 1. Yeah. Yeah. You guys are making it more difficult than it needs to be. It's still not beautiful. So another minute and then I'll go and do it, but it does take some time.
There, are you asking for the first derivative still, or are you asking
No,
for
the
the
whole
third?
thing. See if you
Okay.
can. I'm giving you time to do it. Yeah, first derivative is quick. That should take 10 seconds. That's not even this class. That's first quarter calculus. Yeah, that was supposed to have done a long time ago. And that's not even the first step, isn't even the first derivative. The first step is the 0th derivative after you create your table. Okay, I think I'll work it out because either you're stuck or you got it. One or the other, probably. Okay, or you did it wrong. That could happen too. So let's go work it out. Okay, and I'm going to work it out in a much, yeah. So let's see. Let's see. So the final answer has to have some x's in it, by the way. It's a Taylor polynomial. So let's take a look. We're going to have n. Then we're going to have f super n of x. And then we're going to have f super n of 1. Remember this table? Okay, and n could be 0, 1, 2, and 3 because I want the third degree polynomial. Any questions so far? Okay, the good news is that f0 of x is just the original function. I can just copy and paste it in. And f0 of 1, the zeroth derivative at 1, is just e times tangent of 1. Any questions on the zeroth derivative? Either the 1 is e, but it's easier to type as e. Okay, so that was the first derivative. I mean, that was the zeroth derivative. Let's do the first derivative. So the first derivative, what rule do I have to use? In a word or two? Yeah, product rule. So I take the derivative of e to the x, which is e to the x times tangent of x, plus e to the x times the derivative of tangent of x, which is secant squared x. They both have an e to the x in there, so I can factor out the e to the x, and I get e to the x times 1 plus secant squared of x. Any questions on the first derivative? Any questions on that? Okay, once we have that, now we plug in 1. You just get e times 1 plus secant squared of 1. Any questions on that little piece? Just going to give myself more room. No trig identity.
Yeah, I'm lost. What happened to the tangent when you simplified, when you pulled out the e to the x?
Oh, did I miss it? Oh, you're right. I'm sorry. I did lose it, didn't I? Thanks. Tangent of x. Yeah, that matters. And that's tangent of 1. Thanks. I did lose a piece. Okay, now let's go to the second derivative. What rule do I use? Am I going to use a trig identity? There's not really a good trig identity for this. Yeah, product rule again. And again, I'm going to realize that both the derivative of e to the x and itself are e to the x. So it just factors out, just like before. And what we get is tangent x secant squared of x. And then plus the derivative of tangent x plus secant squared of x, the derivative of tangent x secant squared of x. So I get 2 of them. And then the derivative of secant of x is 2 times the secant of x. And the derivative of secant x is a secant of x tangent of x. So I get plus secant x tangent x times 2. Someone let me say it again. So we're taking the derivative of the secant squared, and that's 2 secant of x times secant of x tangent x, which is 2 secant squared of x tangent x. And let's see if I can make it on. There we go. Any questions on that? Okay, now I just plug in 1. And I get e to the x becomes e to the 1, or just e. Tangent of 1. 2 secant squared of 1. And secant squared of 1, tangent of 1. Any questions on that? Okay, I'm kind of running out of space here for number 3, so I'm just going to put on the next line. It's a little easier. There we go. So now we're looking at 3. I guess I need to do that. Good. There we go. Okay, now we take one more derivative. And when you take another derivative, again, the e to the x is going to stay there. Derivative of the tangent is secant squared. Okay. And by the way, you're going to get all of this stuff second time. And then we're going to take the derivative and add them in. Derivative of the tangent is secant squared, so I get 3 secant squared. Derivative of 2 secant squared of x, that is 2 of what we got before. So that's going to be, we're going to have 3 of them left. And then we're going to take the derivative of the secant squared tangent of x. That's going to be plus. And let's do that. Well, derivative of the secant squared tangent of x, we're going to have a secant squared of x times tangent of x prime, which is secant to the 4th of x. And then plus derivative of the secant squared of x was the secant squared of x tangent of x. And then that's times tangent of x. So we're going to get secant squared of x tangent squared of x. Any questions on that? Then we just plug in 1. It's probably a little messier than I'd give on a test, but again, grabbing these on the top of your head is not that easy to come up with something super easy. So you plug in 1 everywhere. Any questions so far? Okay, what's the last step? Add x. So I don't just put plus x here. Meant for the polynomial. There's going to be some x's in there, but it's not just add x. Okay. Yeah, so let me remind you the next step. The next step is to use the Taylor polynomial formula, which says first term, and I can copy and paste because I've got the first term. So that's just e tangent 1 plus And then you take the second guy, so the first degree piece, and then times x minus 1, because we're centered at 1. And then plus, I guess this plus didn't get put right. There we go. You take the next one. You divide it by 2 factorial, or 2. And then you multiply that times x minus 1 squared. And then the last piece, we plus. We take this third one. In fact, let's do it on the next line. And in fact, that doesn't look good. That's better. So then I'm going to go plus. And now I'm going to take the third degree piece, the f triple prime at 1, divide by 3 factorial, or divide by 6. I'm going to multiply by x minus 1 cubed. And that's it. It's a little messy. When I give you one, it won't be quite as messy, but it's the same idea. Any questions on this example? Any questions? Okay, yeah, the tables, and I find the table is really helpful for these. You could do it without the table, but for me, it just helps me organize. That's why I like the table. And again, I promise you, the one I give you will not be as messy as this sucker. It is pretty messy. Okay, let's there were some other requests. How about the following? No, I can't do it together. Well, I know there was a request for alternating series. So do you want alternating series remainder? Do you want to use the alternating series test? What part of alternating series do you want to see? Alternating series test. Okay. So let's do an example. So determine if the following series converges. Absolutely. Conditionally, or diverges. And the series I'll give you, pop one in. The summation n equals 1, I don't know, to infinity. And these usually have fractions, so let's pop a fraction in. -1 to the n times, how about n squared over n cubed plus 4. So is that kind of what you want to see? Hopefully. Let me give you a couple minutes, see if you can do it. Shouldn't take long, actually. This one's a lot quicker than the last one. The last one was messy. Taylor polynomials are pretty messy. So give it a shot. This one you can do in a minute, probably. Maybe 2.
Larry, if you do the first if it converges absolutely, if you do that test first and you find it does, that you can stop there, right? Because there's no chance it's going to switch around, right?
Right. But let me give you a heads up. That won't work on this one. that
Right,
works if it works.
right. This is just a general question I had because I feel
Okay.
like that was kind of something that
Yeah.
tripped me up a couple
Yeah,
times.
no, if
here
it converges absolutely, you're done. But if you think this one converges absolutely, think again. Just to give you a little hint. Yeah, so yeah, converges absolutely, it's over. You've got it. It converges absolutely. Okay, hopefully you've got it. Let's go over it. Okay, because this one's pretty quick. The first thing you should do is identify and guess whether you think it converges absolutely, conditionally, diverges. What do you think? What does this one kind of look like? If you kind of ignore the +4, I like to do that. So what's your guess of the 3? Yeah, because if you ignore the +4, because as n gets large, the +4 is insignificant. Then it's just n squared over n cubed, which is 1 over n. -1 of the n over n is the harmonic alternating series, and that's a conditional convergence. So that's the first thing. We're going to guess it converges conditionally, because if you guess it converges absolutely, you always go for the absolutely piece first. Okay, on the other hand, we think it converges conditionally. So now let's use the alternating series test. So note that n squared over n cubed plus 4 is decreasing. Okay, and that's because you could do it by taking a derivative using the quotient rule, or you could just say that the denominator is going up a lot faster than the numerator because the denominator is a cube, the numerator is a square. Any questions on that? Okay, and positive. So what we now take, according to the alternating series test, what do we take? You can do the integral test, but you're doing the alternating series test. Remember how it works? We take a limit. It's very simple, actually. As n goes to infinity. So we'll do integral test, but let's first actually show it converges at least somehow. So the limit as n goes to infinity. And then we have n squared over n cubed plus 4. And that's equal to the limit as n goes to infinity. L'Hopital's rule. N squared becomes 2n. N cubed plus 4 becomes 3n squared. And then we can write n over n squared as just 1 over n. And now we get 0. So by AST, the series converges. Any questions on that? Okay, but we want to find out if it converges absolutely or conditionally. So to do that, there's actually a few choices. And I'll let your suggestion go because that works as the integral test. The integral test works here. So does the comparison test, direct comparison test, or actually the limit comparison test with 1 over n. We'll use the integral test. So now we can say the integral from 1 to infinity of n squared. Let's go x squared, sorry. Over x cubed plus 4. Dx. So that's a quick u substitution. U equals x cubed plus 4. Du equals 3x squared. So it's 1/3 times x cubed times ln of x cubed plus 4. From 1 to infinity. What happens when you plug in infinity? What do you get? You don't get 0. What do you get? Yeah, it does not exist or infinity. Therefore, by the integral test, the series of the absolute values diverge. So the conclusion is what? Yeah, it converges conditionally. Any questions on this particular example? Whoops, conditionally. Any questions on that? Yeah, so are you doing the test on absolute values? Yes. Yeah, pretty much every test we've got looks at absolute values. I don't know if you've noticed that. So you either say you must have positive terms or just make all the terms positive. Yeah, so you always do the absolute value. Because if you have negatives, you make them positive and then go with that. Any other questions on that? Let me do another example because it was requested a while back. So determine, how about, do we have time? How about the interval convergence for the summation? And if we're just doing convergence, I don't need numbers. And let's do, whoops. How about n? Because we don't have a lot of time, I'm gonna do a quick one. Times 3 to the n, x minus, how about x plus 2 to the n. Okay, give you a couple minutes to do that. Shouldn't take too long. There's a pretty easy one. Negative a third, 1/3. I'm a little worried about that. For example, when x equals -2, it definitely, or say if x equals, yeah, I'm gonna let you work on this. -2 plus 1/10, it converges, and that's outside your interval. I think I see where you got 1/3, but it wasn't, you made a mistake. Yeah, there's something you didn't do. Okay, we don't have a lot of time, so let me work this out. So what test are we going to use first? Remember, there was a step-by-step process for interval convergence. What's the first test? Pretty much always. Yeah, ratio test. So let's use a ratio test. So we're going to take the limit as n goes to infinity. And then I'm going to take n plus 1. actually write as a fraction. There we go. N plus 1 times 3 to the n plus 1 times x plus 2 to the n plus 1. And what I also need to put in there, absolute value. And then divided by n times 3 to the n times x plus 2 to the n. And that simplifies pretty nicely. So what's 3 to the n plus 1 over 3 to the n? Yeah, so you get 3. And don't forget the absolute values. So you get 3. What's x plus 2 to the n plus 1 over x plus 2 to the n? Not x plus 2 to the n. X plus 2 to the n plus 1 over x plus 2 to the n is just x plus 2. Okay, we have over n, and we had an n plus 1 at the top. Now I could use L'Hopital's rule because I get infinity over infinity. And the nice thing is the 3 times x plus 2, those are constants. Derivative of n plus 1 is 1. Derivative of n is also 1. And I get the absolute value of 3 times x plus 2. And according to the ratio test, what am I comparing that with? Yeah, less than 1. Okay, I could take that 3 and I could divide it. So notice it's not that x is less than 1/3, but x plus 2 in absolute value is less than 1/3. Okay, so that means that x needs to be 1/3 to the left or right of -2. So in particular, the endpoints are, so we're going to have 2 minus 1/3, which is 5/3. And 2 plus 1/3, which is 7/3. Wait, 2 plus 1/3, do I have that right? 3, 6. Yeah, 7/3. Is that right? 3, 6, 7/3. Any questions on that? A -2. So sorry about that. I knew there was something wrong there. So it's -2 minus 1/3 is -7/3. And -2 plus 1/3 is -5/3. All right. What's the next step? I'll do it really quickly. Yeah, we got to plug in and see if they converge. Okay, when you plug in. Okay. And if I plug in -1/3, I get -1/3 plus 2. And I say -7/3 plus 2 is -1/3. So I'm looking at -1/3 to the n times 3 to the n is just -1/3 is -1 to the n. How do I tell if n -1 to the n converges or diverges? What test? The hint is it was the first one that someone asked for. Not alternating series, that won't work, it turns out. Alternating series test fails on this one. Going to use the divergence test. Take the limit as n goes to infinity. Of n times -1 to the n is not equal to 0. So by the divergence test, the series diverges. And then I could do the same thing by plugging in -5/3. And when you do that, you get a 1 to the n, which is just 1. And that's just and same thing. Now we're going to take the limit. I guess I need to pop that guy in too. Whoa. And then same thing, the limit as n goes to infinity of n is not 0. So by the divergence test, the series diverges. So the interval of convergence is -7/3, comma -5/3, not including either endpoint. So that was a little bit out. Sorry, I went a little longer, but I figure can't hurt to review more for the test. But let me stop the share. And let me stop the recording.